We're going to do 1.7, so go ahead and write 1.7 in your notebook. We're going to be multiplying and dividing fractions, and we're going to do some arithmetic with decimals. They want to give you plenty of time over a couple days to actually practice that adding and subtracting of your negatives and positives, okay? All right. Please write lesson 1.7 somewhere close to where you just were. We didn't do a lot on 1.6. We're going to start multiplying. Let's multiply. I actually love multiplying fractions because you don't have to have a common denominator. It makes it really a lot easier. So if I'm going to multiply this 3, is that a fraction?
No.
Can I make it into look like a fraction? It is a fraction, by the way, but it doesn't look like it. Can I make it look like a fraction?
Yes.
Yeah.
3 over what?
1.
Okay, so what I do is I multiply the numerators. 3 times 1 is
1.
how much?
3.
3. And 1 times 2 is?
2.
And can I leave it 2 over 3? Or 3 over 2, I mean?
You could.
I could, and you're allowed, unless the instructions say to convert it, you can leave it, okay?
Or it'd be 1 1/2.
Or it could be 1 1/2. But if you're going to have to do anything with this later, leaving it as an improper fraction would be best. What about this 5 2/3? This would be hard to multiply. What am I going to do to it to make it easier to multiply?
An improper fraction.
Yes, so I'm going to multiply this and add that for how much?
17/3.
17 over 3. And I'm going to multiply here and add there for how much?
5 4.
5 over 4. Are you with me so far? What am I going to do to this?
You're going to see if you can reduce either one of them.
I love that. Can I? He said we're going to see if we can reduce. And the reduce is either on the top and the bottom or the diagonals. Does 3 and 5 reduce?
They're both reduced.
They're already reduced, and 17 and 4 cannot reduce.
Couldn't you just like times the 5? Couldn't you times the fractions and then times the 5?
You can, but you have to. You mean up here? My bad. Wrong thing. This. Yes, you can, but you have to do something. You'd have to take the 5 times the 1 and the 5 times the 1/4. And then you have to do the 2/3 times the 1 and the 2/3 times the 1/4 and add all those things together. That would be way harder, but yes, you can do that. Okay? So we turned it into an improper fraction to make it easier. So what do I do now that I can't reduce?
You just multiply them across,
Uh-huh.
and so then you'd have,
What is 17 times 5? Anybody know?
it is 85.
Yeah, I agree. And then over, what's this?
12.
And then 12.
12.
And just see how many times 12 can go into 85, and then 12 can go into 84 7 times.
So I'm going to let you leave it here, but can I reduce it? If you want to do it Zeb's way, 7, I think it was 7 and 1/12, if that would be, I think if you did your math right, I'm just going by what Zeb said. You can leave it 85 and over 12. Done, okay? It's actually in algebra easier for you to do anything with that later. Unless your textbook tells you to convert it to mixed numbers, leave it like that. All right? Questions about multiplying fractions? All right.
I like multiplying. and
Let's do
dividing
these.
fractions.
Let's do these. Now, I'm going to go with this Zeb thing. Can I reduce? Can I reduce this? It's the diagonals. Does 5 and 4 reduce?
No, but
3 and 9, does it reduce?
Yeah.
So you can reduce first.
1 and 3 you could reduce.
So 3 goes into 3 once and 3 goes into 9
3 times.
3 times. So now I have a 1 times 5, which is,
5, so you have 5 over
12.
12.
all right. What's the advantage of reducing now? I mean, the beginning. Why would you do that?
You don't have to do it later.
You don't. Now, what if you decided not to do it at the beginning? Would you have gotten the answer wrong?
You would just have to reduce it.
Yes, you would have had
As an
15 over 36, and you're going to have to reduce that because that is not done. So you either have to reduce at the beginning or reduce at the end. I actually think that reducing at the end is harder than reducing at the beginning.
Yeah.
So I like the reducing the part at the beginning. All right. And notice I did something for, I think it was Ben who asked me this last week. I made a dot on one of them, and I made a star on the other one. They're the same. Your calculator, if you have your graphing calculator, does this symbol. All right? And most math books do the dots. Why don't we use X, by the way?
Because x is a variable, and it's confusing because it'd be like 3x. Maybe
Yes.
3 times.
3 times. We don't know if it's a times or we don't know it's a variable. So in algebra, we get rid of that whole X, and the only time we use it is for a variable, not a symbol for multiplying. All right, I want you to write this one down on your paper. Write the original problem, please, and I want you to do it, and I want you to raise your hand when you have the answer. compare yours with mine and make sure I'm right. I've got one person who's done. Right here, I got 18 over 5. Did you guys get 18 over 5?
Yes.
And then 15 over 8?
Yes.
Is that what you got? Okay, so when I reduced these by taking a 2 out of each of them, and I got a 4 and with the 8 and a 9 on the 18. Is that correct?
Yes, that's what I got.
And then right here, the 5 and the 15, I think I can reduce by taking 5 out of both of them, right?
Right.
So if I multiply these two,
27.
9 and 3 makes how much?
27.
27. And then I do these two, 1 and 4 make 4. Do I need to reduce the 27 over 4?
It can't be reduced any, but you could make it a mixed number.
I could make it a mixed number. I'm glad that you clarified the difference between the two, because some people think when I say reduced, they're meaning mixed numbers. But can I take anything out of 24 and 27, both?
6 3/4.
Oh, or I can make it 6 3/4, but that's not necessarily reduced. It's just in a different form. So is 6 3/4 something that somebody else got?
I got 6 3/4.
Okay, all right. And so you're allowed to leave at 27 over 4, Ashton and Ben, unless the instructions in there tell you otherwise, okay? All right. Questions about this one?
Nope.
Okay. All right, now we're going to do division. Oh, Aiden, go ahead and ask me your question. All right, we're going to do division. I want you to write this first one down in your notebook for me, please. Write this down in your notebook for me, please. Does anybody remember how to divide fractions? Multiply by the reciprocal. I have somebody who told me at one time it's called KFC, for those of you who love Kentucky Fried Chicken. You keep, you flip, and you change, okay? That's what that stands for. We keep the 3/5. We flip the 9 over 10 to be 10 over 9. And what do I change? The division to multiply. All right. I've got one person who's done. Is that correct?
Yes.
All right. That was pretty fast. Can I reduce anything?
Yes.
I can reduce this right
3
here.
and 9 can go to
I
1
can,
and a 3.
oh, 3 and 9. That's true. So I can make this into a 1 and this into a 3.
Right, and then you
This
can
one into a 1 and this into a
Two.
2.
Oh, yeah, I got it.
So the answer is what?
2 5 over 3.
How much?
5 over?
Careful.
Oh, 2 over 2.
2 over 3. Very good. 2 over 3. Very good.
Oh, yeah.
Okay, you see it?
Yeah,
Okay.
I
All right.
I was thinking the 5 was a 2.
Right. I get it. All right, we're going to do KFC again, but this one I'm going to have to do something worth. What am I going to have to do with that one? Don't worry about writing that one down. Just watch. What am I going to do with this one?
I would make that an improper
Make
fraction.
it to an improper fraction.
Yes, so that's-
And then make it a mixed number.
What is? Make it into an improper fraction. What is it?
24 sevens.
24 over 7. Do you agree with me?
Yes.
It's 20. Yep. Divided by 6.
Times 1/6.
Times how much?
1/6.
1. Oh, very good. This, if it's a number all by itself,
6 and
it's got an invisible 1 on the
24
bottom, doesn't it?
You go to 4 and 1. You can
Oh,
make
so
it.
he's helping me already. He's reducing me. All right, so we're going to this. 6 goes into 24 how many times?
4.
4.
And the answer is this, multiply these two, it's,
4 7. Or 4 times 1 is 4.
and then these two are
7
4
plus 7.
4 7s. Did I go too fast?
No.
That was pretty fast. Ben, did I go too fast? I think I did. So slow me down. Slow me down. I'm going to go backwards. How did I get 24 over 7, Ben?
You multiplied the 3 times the 7 plus 3.
How did I get the 1/6? Very good. And yeah, I agree with that. How did I get the 1/6?
You flipped it.
Okay. So and you were good with that part, right? Okay. Can I reduce anything, Ben?
How are you doing the where you took it, you were putting it down to like 2?
Okay. So what I did is I look at the diagonals. The diagonals right here. These two can reduce. Do you understand how? 6 can go into 6 1 times, and 6 can go into 24 4 times. Now I just have these to multiply, which makes 4 on the top. Do you understand? And this makes 7. And so can that be reduced?
Yeah.
No, I'm done. Did that make sense to you now? So I slowed down. All right. All right. Let's do I want you to do these in your book. I don't know what page they are. Go ahead and raise your hand when you've got those 3 done. All right, let's grade it up there. I got 3 over 5 times 1 over 4. I got 3/20. Raise your hand if you got 3/20. Okay, fantastic. Now, how many of you got 4 over 1 times 17 over 8 in your work that you were doing? I've got 1 person who agrees with me. 2 people agree with me.
I got 19 over 8.
Yeah, I got
19 over 8. 16. Oh, that's true. Thank you. That is 19 over 8. Good thing I didn't finish. 19 over 8. Is there some things I can do to reduce this?
Yeah,
4 and 8.
I can reduce which ones?
4 and 8.
The 4 and the
The
8?
other 1 and 2.
Okay, so I'll have, what's the answer going to be then?
9.5.
Or 19 over 2.
19 over 2. Now, does the instructions tell you to leave it as does it say to change it? It just says to multiply, so you can leave it 19 over 2.
What?
Okay?
Oh, well,
All right. Okay, so this is 3/5. 3/5
Yeah,
times what?
I know that. You want me to say the answer?
I need you to, you guys need to be showing me some work on your homework, so don't be just doing the answers. What's the, because your calculator can get the answers for you. I showed you last week how to make your calculators do fractions, so you need to prove to me that you know how to do it without your calculator. So what 3, how much?
3/5 times.
Yeah.
5 over 2, that's right, 5 halves. Very good. Can I reduce anything?
5 and 5.
The 5 and the 5. I agree.
So you just have 3 over 2.
So we just
or
have 3 over
1
2?
and a half, or-
And you can leave it.
I did 1.5.
You're allowed to write as much as you want. Write me 12 sentences if you want, but I only need a 3 and over a 2. Okay? You're allowed to give me 1 and 1/2. All right. All right, now we need to do stuff with decimals. This unit also has things with decimals. If I'm going to add these two, what do I have to do to add decimals? This is review. What do I have to do to add decimals? I have to line up the decimals. And which one do you like to put on top? Do you have a preference? It really doesn't matter, but I do like,
I would put the bigger.
I like the long, when I say longer, bigger, I mean longer. I like the longer one. So I like, because this could be, depending on where the decimal is, that one could be technically smaller, but I like the longer one. Oops, back up. Here we go. I want 207.351. Okay, so then what do I do with that 23 point? I put the decimal there, and I want the 20 and the 3, and I have a 4. I could put extra zeros in here if I want, but I don't have to. And then I just add. Are you with me? Go ahead.
I was just saying I had it.
You got it. What did you get for the answer?
230.751.
Did anybody else get that?
Sure.
Sure, they said. Is that what you got, Aiden? Yeah, okay. What if I'm going to subtract? Is there any tricks for subtracting?
Just minus the
Is that answer going to be negative or positive when I'm done?
and the other thing.
Positive.
How do you know?
Because the positive is the bigger number.
Yes, the positive is has a larger magnitude, I agree. So we're just going to line up the decimals like we did before. We're going to do 14.2, and we're going to subtract. I like to put the decimal there, 6 and a 9 and a 2. Oh, whoa. I have a 9 and an 8, by the way.
You
How
can
do-
just put a 0.
That's what I'm going to do. Then I have to borrow, and I have to borrow. So I have a 2, that's a 13, so I'm going to have 7. Is that what anybody else got, 7.22?
Nope.
That's what it said. Yeah, you're right, Miss Carrie. I believe you, Miss Carrie. You're really smart, Miss Carrie. I believe it. All right. Has anybody else got it for real?
I got 7.32.
3-2. Did I do this wrong?
Let's take
Would you not make the 2?
No, because they borrowed. It borrowed to a 10.
Yeah, I had to borrow from the 2 to make that a 10.
Okay, I see it.
You see it? Okay. Anybody else? Is it 7.22? Is that what you got? Okay. All right.
Over.
Now, multiplying. Do I have to line up the decimals to multiply?
No.
Nope.
Okay, so I just line up the numbers like I do the 9.32, and I put the 5 at the end and the 3.5 like that. All right. So I multiply like I would multiply normal. I do 5 times 2
Then you just add the decimal
is 10.
places.
This is 15, 16, and these two are 45 plus 1 is 46. Are you with me so far?
Yes.
Some people put a little place value 0 in there. You can if you want. It's up to you. Then
I do.
Then I like to erase all my little ones at the top because I get confused of all those extra ones. So then here we go. That makes 6. This makes 9. And this makes 27. And I'm getting too big a space here. So I need to make it littler.
I'll get it.
Okay, somebody's already got it. So make sure I'm right. 0, 12, 16, 7, 8, 12, 3, 3, 2, 6, 2, 0. And then what do I do with my decimal though?
You gotta go 32.62
How did you know that?
because you have 3 places and you move.
Yes, so I have
You move
1,
the
2,
decimal.
and 3. So I have to go 1, 2, and 3. So it's right here. That's the trick with the decimals when we're multiplying, okay? You have to count how many there were and stick it in. 32. Do I need the 0 at the end?
No.
I don't, but you can write it if you want. All right?
Well, there's infinite zeros after.
There's an infinite number of zeros afterwards.
Right.
Now, and
A million.
if we're not talking about what we call significant digits, which you'll have to figure out that later, you don't have to write it. Okay. Oh, division. Yay! Okay, which one goes inside the division symbol? The 13.8 or the 0.33?
0.33 goes outside.
Goes on the outside?
The
This
33 goes
this
on the
this
outside.
sentence says 13.8 divided by 0.33.
Yeah.
So the first thing goes where? The outside or the inside?
Inside.
Inside.
0.23 goes on the outside.
And the 0.33, and I should put the 0, I tend to not, but now how in the world do I do this one?
Well, you move the decimal place 2
Okay,
spaces on
so
the
I move this
33.
decimal over 1, 2, and if I move it there, I have to do
You
what?
gotta Move 2 on the
Move on the inside. Okay?
and then you
So
put a
now I
0
have to put a little 0 right there, and my decimal's now up there.
Right.
Those of you who don't like to write very much and keep all these details, you need to put your decimals up there. And you need to line things up. Does 33 go into 1?
No.
Does it go into 13? It goes into 138. About how many times do you think it goes in there?
A bunch.
4.
He thinks about 4.
Yeah, that's about right.
Okay, about 4. So I put the 4 above the 8. Okay?
Alright.
So what's 33 times 4?
33 times 4.
132.
How much?
132.
132. Is that correct?
Yeah.
Yes. 132. He did a good job of guessing. Not 8, but 2. I subtract. That makes 6, and then bring down my 0. How many times does 33 go into 60? 1 time, and I put that right next door. 33. What's 60 divided by 33? Subtract.
4
How much?
26. 27.
27.
27.
All right. Got to bring down that 0. That's there, invisible 0. How many times does 33 go into 270?
8 times.
How many?
8.
Is it equal, even?
No.
Let me just see something real quick before we do. Make sure that I needed to know how do they keep going forever and ever?
Yeah, it looks like it.
They do. Okay, so then 8 times, how much is 33 times 8?
264.
264. Subtract, what's 270 minus that?
6.
6 again. Oh. Am I going to have a repeat?
Yes. 44.81818188.
Ah, it's going to do 8181 and it's going to be repeating.
Do 8-1 with a bar over.
Yes, 41.81 with a repeat.
Or
8181.
you could,
Yes.
You could round it. Like,
You could round it. It depends on what the instructions tell you. Exactly right.
you could
So if
The
they,
100th place,
because they could just say, if they told you to do it to the 10th place, it would be 41.8. If they told you to do it wherever, you just need to look at the instructions. Okay?
41.82.
Yes, or 41.82, depending on what the instructions tell you to do. That's right. All right? So make sure you follow the instructions. My point was I wanted you to remind you how to do all these. I want you to get out. Wait a second. We're not going to do any assignment problems from the book this time. Okay? All right.
Low battery.
Yes.